Red blood cell indices are specific numbers that we get from our red blood cell calculations that happen within the machine, from the automated machine. And this is going to help us get specifics on red blood cell size and red blood cell color. And this is even more accurate than just a quick glance at the slide. We always want to look at the slide to correlate with these numbers, but this is actually what pathologists use more often to determine red blood cell size and color for this slide as a whole. So that's what we're going to talk about today. The red blood cell indices are basically a relationship between the PCV or hematocrit, the hemoglobin amount, and then the red blood cell count. And this is really good information for trying to ID different kinds of anemias and trying to verify what we're seeing on the red blood cell morphology on the blood smear. We use this mathematical method to ID cell size and color. It's really important in the anemic patient. If we have a patient that has normal red blood cell indices, we generally don't get too concerned about it. We do correlate that with the slide, of course, but it's most important for determining cell size and color in our anemic patients. Obviously, in order to get accurate red blood cell indice numbers, we have to have normal red blood cell count, hematocrit, and hemoglobin. So a machine still needs to be working properly. And again, going back and looking at that slide is going to help us determine if we're getting the appropriate values from the machine. And that just comes back to the blood smear. Our automated machines are really important and extremely helpful, but the eyes and the knowledge of a technician is really going to be important to correlate these two information systems. So the first indice that we're going to talk about is mean corpuscular volume. I also like to refer to this as mean cell volume. I think that makes sense since we refer to these as cells and corpuscles. But mean cell volume is basically the size, the volume of stuff that's inside our red blood cells. So this is going to measure the average volume of a red blood cell in cubic microns, or the other term we use is femtoliters, or F_L. And it's going to indicate if our average red blood cell is normocytic, which we want to see, microcytic, which is too small, of course, and then macrocytic, which is larger than we would expect. The packed cell volume is kept as a percentage in the calculation for this. I actually removed the calculations from this PowerPoint. You guys have those in your notes if you need it, but generally we are not calculating this. These are calculations done by the machine, so I'm not going to have you worry too much about those. We just need to understand that MCV is a determination of our average or mean red blood cell size. Normal value for a dog is between 60 and 77 femtoliters. Cats, because they have smaller red blood cells in general, the MCV on these guys is going to be 39 to 55 femtoliters. If we have a value below the normal range, for instance in this image where we see the value is less than 60 femtoliters on the left, then we have a microcytic sample. Within the normal range we have a normocytic sample, and then above the normal range is macrocytic. So here's an example of a CBC from an automated machine, and I'm going to focus your attention down to the red information down here, which is the red blood cell information and the red blood cell indices. So at the top, first of all, you'll notice that we have a normal red blood cell count, 4.59. Normal for this patient is 3.8 to 5.1. But the MCV is right on the borderline. MCV is 80. And for this particular patient, this is a human, apologies, but 80 to 98 is the normal range for a mean cell volume in femtoliters. And you see this patient is right at 80, so we're on the low end of normal. So we would expect the cells on this patient's blood smear to be trending toward microcytic because we're on the low end of normal. So here's an example of what we might see. This would be a microcytic anemia in our patient where the MCV is low. It's on the low end of normal. So here's a normal lymphocyte for size reference. You can see the nucleus of the lymphocyte, which is what we should be using to gauge approximately red blood cell size. You can see most of our red blood cells are considerably smaller than the nucleus of the lymphocyte here, and some of them are quite a bit smaller. Now, sometimes there can be errors on the MCV, and this is why we are going to check a slide. If we have a mixture of microcytes and macrocytes, like you see in this image here, if we have anisocytosis, that could average or mean, our mean could come to a normal MCV. If we have an increase of reticulocytes, like we see in this sample here as well, or polychromatophils, that could increase our MCV as well. And then sometimes the red blood cell count on the machine could be incorrect if it's overcounting or undercounting for some reason. So this is why we're always going to check a slide. We're also always going to check a packed cell volume to compare to our hematocrit to make sure that our red blood cell count is trending normal on our automated machine. The next value I'm going to talk about is the mean corpuscular hemoglobin concentration. And again, just substitute the word cell for corpuscular. So the mean cell hemoglobin concentration. And this is basically an average of the amount of hemoglobin in all the red blood cells. So this is going to measure the ratio of the weight of the hemoglobin to the volume of a red blood cell. And the value we're using here is grams per deciliter. So this is going to tell us color. So MCHC equates to color, whether our red blood cells are normochromic or hypochromic. And so here are a couple of examples here on the right of some hypochromic red blood cells. And so you would end up seeing that these, the MCHC for these cells would be low. So what does that mean? So normal values for a dog for MCHC are between 32 and 36 grams per deciliter, so a relatively small range there. And for cats, it's 30 to 36. And that's simply because we really can't have more than about 36 grams per deciliter of hemoglobin in the average red blood cell sample. And so if we have a result within the normal range, we're going to call that a normochromic sample. Results below the normal range, so if our MCHC is below 30 in cats or 32 in dogs, then we would expect to see what you're seeing here on the slide, which is a hypochromic sample. So you can see a lot of increase in central pallor in all these cells. They really don't look very well filled at all. I think I can see one normal red blood cell on this whole slide that has the appropriate amount of hemoglobin within the cell. So this is a very hypochromic sample. Also, very large and excited looking platelets on the sample too. You really won't get anything that's above normochromic. Then we just generally call those cells well filled. And because of the math that's involved, and again, I don't really care if you know about the math, but because of the math that's involved, it can't really end up with more than 36 grams per deciliter of hemoglobin. But we were really more concerned about a hypochromia rather than a well-filled situation. And here's that CBC again, and to highlight here, the MCHC on this patient is 29, normal is 32 to 36, so similar to a dog. And you can see MCHC here is 29.8, so that's low. So you would expect to see hypochromia on your blood smear. Let's take a look. So here's the blood smear for this particular patient, and you can see it is correlating with the MCHC. You can see a lymphocyte there on the bottom left side, and that nucleus is quite a bit larger than those cells. So we also have a microcytosis as well. But more importantly, for what we were talking about, is that these cells are incredibly pale. Again, I see one, maybe two cells on this whole slide that have a normal amount of hemoglobin within them. Otherwise, lots of central pallor on these cells, a definite hypochromic, and likely anemia going on here. All right, and then the last red blood cell indice is the one that we always go, we don't care about it. It's the mean cell hemoglobin. And really the reason this one isn't that important is because if it doesn't agree with the MCV, which is the mean cell volume or the size of the cell, or the MCHC, which is the mean cell hemoglobin concentration or the color, then we don't really put much emphasis on the MCH. It's going to agree with MCV and MCHC. It's going to show us that we have a normocytic normochromic, or that we have a microcytic hypochromic, or some combination of that. It's not giving us additional information. So just know that it's there. We have some normal values, and these are measured in picograms, or PG. And then again, if we have a normal range that you're seeing here, 19.5 to 24.5, or 12.5 to 17.5 in cats, that's going to be normal. Anything below that, we're going to say that that's hypochromic and microcytic. And then we're going to look at our MCV and MCHC to see if that's correct. And most importantly, we're going to look at the slide. Okay, so some recommendations for reporting these red blood cell indices. You need correlation, and I've mentioned this several times. We need to correlate the indices and what you're seeing on the smear, so the appearance of the red blood cells. If they don't equal each other, they don't look like what you're expecting, then there's a problem somewhere. So it's either in the way that the slide was made, or perhaps in the automation of the machine, and we might need to run that sample again. Again, you're going to use that nucleus of a small mature lymphocyte to compare to the size of the red blood cell. This generally works really well in the dog, not as well in the cat because they have smaller red blood cells, but you can kind of extrapolate from there with the cat and expect slightly smaller red blood cells. And then, everything should correlate. Got to look at that slide. If you have a low MCHC, you would expect to see hypochromic cells. If you have a low MCV, you would expect to see microcytic cells. If you're not seeing those, you might need to rerun the sample. So you're going to check your instrument, check your calculations, evaluate the slide, and make sure that your differential results are accurate in order to correlate the slide with the automation. So sometimes we need to run samples a couple of times. Sometimes we need to draw more blood in order to get an appropriate sample for these guys that are having abnormal results. So that's the end of red blood cell indices. This is a good intro for when we start to talk about abnormal red blood cells. So that could be the next one that you watch, or you can jump right back into maturation. And I'll see you in the next one.